have time of flight mass spectrometer, which determines isotopes that are present, and that helps us identify. Identify the element. So we have to make sure that it's in a vacuum so that air particles don't get ionized and don't get registered, because we just want to know what the element is. So the first step that happens in the mass spectrometer is ionization. And this can be done in two ways. Something called electron impact and electrospray ionization. So in electron impact, the vaporized sample, the vaporized sample is injected at low pressure. Then an electron gun is used to fire high energy electrons. This knocks out an electron and that forms the ion to be formed with different charges. That's the only thing I've got. So for example, like if we were to make a equation with, like, for example, Ti in the state of gas, arrow Ti plus in the state of gas plus E minus. Then the other one is electrospray ionization. And what happens is that the sample is dissolved in a volatile polar solvent. And so the sample is dissolved in a volatile polar solvent. And it's injected through a fine needle. So it's injected with a fine needle. Injector giving a fine mist. So giving a fine mist, or you can call it aerosol. Yeah. And we need to remember that the tip of the needle has high voltage, right? Yes. Tip of the needle, high voltage. So what the steps we've just gone through. So the sample is dissolved in a volatile polar solvent. Polar is important, and so is volatile. So it's injected with a fine needle, giving a fine mist. And the tip of the needle has a high voltage. So the next step is, at the tip of the needle, the sample molecule gains a proton. So at the tip of the needle, so the tip of the needle, the sample molecule gains a what's it called? A proton? Yes. Sample molecule gains a proton. Okay. H plus from the solvent. So H plus. Okay, I have to try to remember this. So, electrospray ionization. Sample is dissolved in a volatile polar solvent. Oh my gosh, I actually got the first one. Then it's injected. It's injected with a fine needle. Hold on. Oh, giving a fine mist. Okay. So sample is dissolved in a volatile solvent, polar solvent, and then is injected with a fine needle. And then it gives a fine mist or aerosol. The tip of the needle has high voltage, and the tip of the needle also, the sample solvent gains a proton. Yes. Okay. So H plus. The solvent evaporates. While MH ions move towards the negative. So solvent evaporates. So solvent evaporates, and then the MH plus goes towards the negative plate. So that's the difference between electron impact and electrospray ionization. Okay, it's not that difficult actually. I just feel like it will be kind of difficult to remember this. But let's see how much I remember. Okay, electron impact. Okay, the vaporized sample is injected at low pressure. Then an electron gun is used to fire high energy electrons at at what? Oh yeah, the sample. And this causes an electron to be knocked off. And then it forms a proton? A positive ion. Okay, I guess I was close enough. And then the equation, it goes like, it can be any element, but in this case we have Ti. So it'll be Ti in the state of gas, arrow, Ti plus in the state of gas as well, plus E minus. Oh, yes. Okay, so electron impact. I am a genius. Okay, next one. Electrospray ionization. Okay, the sample is dissolved in a volatile polar solvent. Polar. Yes. And is injected with a fine needle. Okay, I kind of cheated. I looked. High voltage. No, it gives a fine mist. Okay. Okay. I need to remember this. Okay. I'm covering it. I'm not going to look. The sample is dissolved in a volatile polar solvent. And then is injected with a fine needle. Yes. And produces a fine mist. And the tip of the needle is high voltage. And the tip of the needle causes a proton to be formed, right? Gains a proton, not forms it. Okay, it was close enough. So H plus, and then the solvent evaporates, and the MH goes towards the negative plate. Yes, I knew I could do it. Yes, actually, I'm actually so proud of myself right now. So that's good. Okay, so the difference between them is that electrospray ionization is actually used for larger organic molecules, and it's like softer conditions, whereas electron impact is causes larger organic molecules to fragment, so we don't want that to happen. Well, actually, no, I don't know. I guess it depends. But anyways, that's what we have to remember. Okay, so after ionization, we have the beautiful acceleration. And as you can already guess, it's something about speeding up. So acceleration. So acceleration, positive ions are accelerated by an electric field to a constant kinetic energy. So positive ions are accelerated by an electric field, but they all have the same kinetic energy. Have this kinetic energy. So we say that we have K, M, and V. So the equation is V equals big fat square root 2KE over M. Given that all the particles have the same kinetic energy, the velocity of each particle depends on its mass. Lighter particles have a faster velocity and heavier particles have a slower velocity. You don't need to learn the equations, but maybe ask to rearrange them and use them in a calculation. Great. Okay, that's fine. V equals 2ke over we know anyways. And where's my calculator?